All right, take out a piece of paper, write down review assignment number 9. Let's do it together. Do this assignment to learn it, not just to copy the answers down. All right. In number 5, let f be the function given here. I've already kind of worked at it a little bit. And it says answer some of these questions. These are really good questions for you to be able to do because some people are struggling with this. What's g at 3? Plug in 3 for x. And so what does that mean? Find the area from 2 to 3. So we're going to write down what we're doing. So if I want to find g at 3, I'm finding the area from 2 to 3. And that area from 2 to 3 is a trapezoid. So if I just go 2 to 3, that's a trapezoid. And then the area of a trapezoid is 1/2 the width. So it's 1/2 the width, and then you add the two heights. So one height is 4, and then the second height is 2, and that's it. If I wanted to answer it, that would be 1/2 of 6, which is 3. The derivative. Well, the derivative of x is just f at x. So when you're asked for the derivative at 3, you're just asked for f at 3. So you look off the graph and go, what's the y coordinate when x is 3? So the answer is 2. When you're asked for the second derivative, you go again. So the first derivative is f at x. The second derivative is the derivative of x. So when we look off the graph, what's the slope at 3? So if I look at 3 and I go, okay, what's the slope at 3? It's negative. We go down 2 and to the right 1. So the slope is -2. Not difficult, but you have to listen and learn, right? In terms of the area, just a point, or the derivative is the slope. Find the average rate of change. That's an integration question. From 0 to 3. And then you divide by the difference of the bounds. That's average value. I'm going to write that as 1/3. Now, so I got this right. Oh, average rate of change. I did the average value, so let's not do that. So the average rate of change from 0 to 3, you would have to go g at 3 minus g at 0 over 3 minus 0. Just the slope formula. So we already know g at 3, because we did it up here. That number is 3 minus, we don't know g at 0, so I'm going to do that right here. So g at 0, you plug in 0 for x, and then find the area. Now, I want you to recognize that the bottom number is bigger than the top number. You're still going to find the area from 0 to 2. But whatever the answer is, you do the opposite number. So if I look at the area from 0 to 2, it's a triangle, half the base times the height. So from 0 to 2, half the base times the height, that's going to be 4. But we do the opposite, so it's going to be -4. So the average rate of change is 7 over 3. For how many values of c between 0 and 3 is the derivative equal to the average rate found? So again, the derivative is just f at x. So in terms of that, we're just looking at f at c. How many times is it equal to 7 over 3? Which is about 2 1/3, or 2.3. So how many times, how many y coordinates would share that with the x? So if you draw a horizontal line at like 2.3, how many times does it cross the graph? And you can see it crosses twice. So there are 2 values. All right? Part D. Find the x-coordinate of the point of inflection. So the point of inflection is the second derivative. So we know the second derivative is equal to the first derivative of f. So we're trying to find the second derivative, which is equal to the first derivative. And for the point of inflection, we want to see where it's equal to 0. Now, where is this equal to 0? We're looking for the turning point on the graph. So at what x values do we have turning points? So if I look at x equals 2, we have a turning point. and at x equals 5, we have a turning point. Those are both point of inflections. So it changes from increasing to decreasing, or positive to negative, or negative to positive. Those two are my point of inflections. All right, there's our first question. Number 6, 2 on here. So in number 2, you're given a simple graph, which is x squared and y equals 4. And it's shaded in for you. And the question is, find the area of that, which should be simple enough. That's an integration question. To find the bounds, you make them equal to each other and solve it. So if you square root, the two bounds are positive and negative 2. So we're going to go from negative 2 to positive 2. To find this area, I go top, subtract the bottom. And then I integrate it. So 4 is 4x, and then x squared, you add 1 to the exponent and divide from negative 2 to 2, and then we plug in. So we first plug in 2, subtract, and then you plug in negative 2. And that's it. That's the area. You don't have to simplify it. If you did simplify it, it would be, let me give you the answer if you did simplify it. So if you did simplify it, it would be 256 pi over 5. That's going to be a little bit easier for the next question coming up. Not the next one, but pi. Next one coming up. B. Oh no. Sorry, this would be 32 over 3. That would the answer be. All right, next one. Find the volume if you rotate it around the x-axis. So if you rotate this around the x-axis, that creates a circle. And is there a space between the curve and the x-axis? Yes. So that means it's a washer, which means there are two radii. So we're still integrating from negative 2 to 2. Two circles, so pi r squared minus pi r squared. And we have a big radius and a little radius to set up. So for the big radius, you go from the top all the way to the bottom. That's 4, take away 0. And then for the small radius, you go from the curve, subtract 0. So that's x squared, take away 0, or just x squared. Now there's the setup. We actually have to find the volume. So that is 16 minus x to the 4th. And then we're going to integrate. So that's 16x. That's x to the 5th divided by 5. And then we're going to plug in. So we first plug in 2. Subtract, and then we plug in negative 2. So that's a great answer. We are going to simplify that to help us with the next question, so I'll do that for you. That's 256 pi over 5. The last question is, there exists a number k where k is bigger than 4, so that when it's revolved around the line y equals k, the resulting solid has the same volume. So I'm going to draw another line above that, up here somewhere, and the line is y equals k. And so there exists something there above where if I revolve it around that, it will have the same volume. So again, I need to set up for volume in terms of revolving around. So the big axes will be top subtract bottom. Oh, sorry, here. It's going to be in here. Top subtract bottom, which would be k subtract x squared. And then the second one's going to be k subtract 4. The big radius, and because it's above. And there's the setup. And it's equal to that volume. So this is the setup, equal to that volume, and then find that k. All right, number 2 is done. 3 more left. For the next one, a particle moves along and has a velocity. For this velocity, it's going to be easier to expand this. So I'm going to do that first. So t times t is t squared. t times negative 3 and negative 1 times 2. If you combine it together, it's negative 4. And then a negative times the negative. And then if I multiply it through, I get that as the velocity. The first question says, find the minimum acceleration. So the acceleration is 6t minus 12. Remember, this goes from 0 to 5. And so the derivative of that, to find the minimum acceleration, is 6. That means the acceleration is always positive. So the minimum acceleration is at the very beginning. So the acceleration at 0 is negative 12, and it just increases from there all the way through from 0 to 5 because it never decreases. It keeps increasing. So negative 12 is the minimum acceleration. Part B. Find the total distance. So we get to have a calculator here. So the setup for total distance with a calculator is this. We're going to integrate. So we're going to integrate from 0 to 5. We're going to integrate the velocity, 3t squared minus 12t plus 9. And for total distance, it's the absolute value of the velocity. Type it in, press pause, see if you get the same answer as me. And the answer should be 28. In part C, find the average velocity. That's also an integration question, not absolute value. But you have to divide by the difference of the bounds. So you have to divide by the difference of the bounds. Type that in your calculator, and you should get the answer 4. All right, 2 more. In number 4, a function f is continuous and closed on the interval from negative 3 to 3. It says f at negative 3 equals 4, and then f at 3 equals 1. And then it basically gives you number lines for the first and second derivative. So from negative 3, this should be positive 3. From negative 3 to negative 1, it says it's positive. From negative 1 to 1, it's negative. And then from 1 to 3, it's negative again. So that tells me there is a maximum there at negative 1. Then, for the second derivative, from negative 3 to 3, so negative 3 to negative 1 again, it's concave up. And then negative 1 to 1, it's again concave up. And then from 1 to 3, it's negative, which means we have a point of inflection at 1 because there's a sign change. And then it asks us some questions. We're going to graph this first, at least a sketch. And the sketch goes from negative 3 to positive 3. So at negative 3, it's 4. And at 3, it is 1. And then I'm going to use this to do a sketch. So from negative 3 to negative 1, it's increasing and concave up. So I'm going to do that all the way to negative 1. So increasing and concave up to there. Then it decreases, but it's still concave up to 1. And you can see why the derivative doesn't exist because there's a corner there. And then it continues to decrease, but now it's concave down. And you can see there's a point of inflection right there. So this is actually part C. In part A, it says, what are the absolute max and min? So you can see at x equals negative 1, we have an absolute max. And then the minimum is at x equals 3, we have an absolute minimum. What are the x coordinates of the point of inflection? Well, we know that's at 1. So at x equals 1, we have a point of inflection. And then you're asked to do the graph, putting this together. All right, one more left. We're given a function. and we're told p is a constant. And then part A says, use the derivative, that's 3x squared minus 12x, because the derivative of a constant is 0. And find the relative max and min. So first we're going to make it equal to 0. Factor out 3x. Then we're going to solve it. So the two solutions here, the critical numbers are at 0 and 4. We're going to draw a number line for that, for 0 and 4, for the derivative. We want to know where it's increasing and decreasing. So pick any number smaller than 0 into the derivative. That's negative times the negative. Pick any number between 0 and 4 and plug it in. So like 1, that's positive and negative, which is negative. And then when it's bigger than 4, that's a positive times a positive. Now, this tells me we have a maximum there and a minimum there. So I'm going to plug in 0. And if I plug in 0, the answer you get is p. That's our maximum. I'm also going to plug in 4. So 4 cubed is 64. 4 squared is 16. So this is 64 minus 96, which is 32. So that's negative 32 plus p, and that's our minimum. And then in part C, or that's all part A, part B, find the average value. So for that we integrate from negative 1 to 2. And we're going to integrate the function x cubed minus 6x squared plus p, and then divide by the difference of the bounds. And we want to know when that's equal to 1. And then we would solve that equation for p. So we're going to integrate. So we're going to add 1 to the exponent and divide. We're going to add 1 to the exponent and divide. And then p would be px. And that's from negative 1 to 2. Now I want you to see this, that 2 subtract negative 1 is 3. This is 1/3. So we're going to put that in front, equal to 1. So as we solve this equation, I'm going to multiply both sides by 3, so I don't have to deal with that fraction. Now, for this, I need to plug 2 in first. So we have 2 to the 4 over 4, minus 6 times 2 to the 3 over 3, plus p times 2. Subtract. Now I'm going to plug in negative 1 to the 4. That's positive 1/4. Negative here, a negative and a negative is 6 over 3. And then negative would be negative p. And then I'm going to solve this. So first the p's, 2p, when you subtract a negative it's adding, so it's 2p plus 1p, so that's 3p. And then, man, all of this I just need to get onto the other side. I don't even need to simplify it. So I have a 3, I'm going to subtract this, just not in that mood. I'm going to add this. As long as it's numerically equivalent. This is that. I'm going to add this. I'm going to subtract that. So I'm going to add that. And then at the very end, I'm just going to divide by 3. And it looks super ugly, but you know what? That's way easier than trying to simplify that in terms of free response. Anyways, Mr. G Math over and out. I'm proud of you for doing your review, trying your best to learn it and not just copy. I like your questions and figuring this out together. Till next time.